3D printers are a fun new technology that many of us have heard about without really knowing much about what they are. So what is 3D printing? At its most basic, a 3D printer creates a three-dimensional model from a digital file using whatever material you load into the printer. It works the same basic way as an office printer. An office printer uses the raw material of paper and toner to create prints from the computer file that you send it. A 3D printer works in the same basic way, but the three-dimensional model is three-dimensional rather than a flat image on a piece of paper, and it uses very different materials. A basic 3D printer, the kind you're most likely to encounter, prints in plastic, like this one right here. You feed a particular kind of plastic into it, it melts it and forms it into your model. The technology is very adaptable, however, and there are 3D printers out there that print in all kinds of materials. For instance, there are 3D printers that are bigger than houses because they print houses out of concrete. There are also 3D printers that print food. Now, this is not like the food replicator on Star Trek. It's not creating food out of nothing. Instead, you feed it pasta dough or pancake batter or chocolate or whatever, and it uses a three-dimensional digital model to create a three-dimensional shape out of that material. Even with plastic 3D printers, there are lots of different kinds, but at heart they all do basically the same thing. The most common type of 3D printer uses a technology called fused deposition modeling. You don't need to remember that, there's not going to be a test. The easiest way to understand it is to think of a 3D printer as a really fancy computer-controlled glue gun.
Thanks, Crystal. Welcome to Idea Studio's video badging for our Prusa MK4S 3D printers. You might notice this printer looks a little different than the one that Crystal was demonstrating. That's because it's an upgraded model in Prusa's Mark series of printers. That's what the MK stands for. In this video, we are going to go over how to use the equipment and the software that goes with it to get you badged and ready to use our 3D printers. After the video, we'll have you set up a skills test in order to complete your badging, where we'll go over hands-on use of the equipment. To begin with, we are going to go over the basic parts of the machine. One thing to note is that when you come into the space, the printers will be in an enclosure. What that mainly means is that the spool holder might be a little more difficult to reach, and the filament will be a little trickier to thread into the enclosure in order to load into the hot end of the printers. Here we have the plastic filament, which we provide in a variety of colors, loaded onto the spool holders. The filament is threaded, cascading over the top into the hot end of the extruder, which gets to be about 500 degrees Fahrenheit to melt the plastic, so you don't want to touch it and you want to be very careful around it. The extruder pushes the melted plastic out onto the magnetic build plate and builds your model up layer by layer. The magnetic build plate is on the heat bed, which also gets hot, but not nearly as hot as the extruder. It's about warm to touch, so you do want to be careful around that. The build plate is magnetic and removable. When you're ready to remove the plate at the end of your print, you'll put your fingers under the overhang in the front corners of the plate, pull up, and then pull back towards you. The build plate is also flexible, so if you need help to remove your print, you can try by flexing it, and you don't want to overflex it. And if that doesn't do the trick, then you're going to want to use a tool with rounded corners to help scrape it off. Also note, the heat bed says do not print, so make sure that if you're going to start your print, the build plate is on the heat bed. Also note, when putting the build plate back on the heat bed, the notch back here, that will line up with the pins at the back of the heat bed. So to put it back on, we'll just go in reverse order, where we line that notch up with the pins, and then we'll release before the build plate goes to the heat bed, because otherwise you might get a little pinch on your fingers. Also, be sure to replace the build plate glue side up. And then below that, we have the control panel. The control panel is a graphics display screen that can be controlled by turning the dial knob and clicking it in to select, or by touch. It's a little harder to press these options when you're in menus like this, so we recommend using the dial knob when selecting anything in these submenus. And just in general, because it can be a little easier to control. You'll never have to worry about the options down here. The only ones you'll be interested in selecting are the three on the top row. What we're going to do now is a filament change. In order to start that process, we could preheat our filament. So we'd scroll over and select preheat, And the only filament we carry is PLA. So whenever you see this menu, you're always going to select PLA. But we'll go back and go to filament. And now we have some options here. If we selected unload filament, that would also start heating up our filament in order to unload. But if we're going to do a complete filament change, we can go ahead and select change filament. Once you select change filament, the printer will begin heating up in order to unload its current filament. Depending on if you went into preheat mode first, this process may take a little longer. You'll be able to see the temperature build up here and your progress bar for when it's ready. Now the filament will unload in 2 phases. That was the first one. And then you want to wait until that second one so it fully releases. Once it reaches 100%, it asks us if the unload was successful. If it was, we can select yes. And now it asks us to remove the filament if it's still in the hot end. You can pull the filament out, clip it at an angle, and then store it. And to properly store the filament, we don't want to release it until we have it nice and secure in a hole on the side of the spool. Otherwise, it might get loose and turn into a tangled mess. Once the filament is removed, it'll ask us what filament we're going to load. And since PLA is the only filament that we carry, we can select PLA. Now, it'll ask us to load the filament into the sensor of the hot end. I have my new filament right here ready to go. It's secured and the edge has been clipped at an angle so it's ready to be loaded. If it wasn't clipped, I can take a wire cutters and do the clipping myself. So I'll just take the filament out right here, and again, I want to make sure that it'll be cascading over the top and not coming underneath, because that makes it a little more difficult as it's feeding through into the extruder. So I can put my filament onto the spool holder, and for this particular spool holder, I'm going to feed it through up here to help guide it, and then I will put it into the hot end. Once we have it loaded in, we can select continue, and it'll grab the filament. And then once you feel it pull, you can release. And now we see that the printer is loading the filament, and what we'll start to see is that it's going to begin to extrude or purge that older color, and then we'll be able to see a color change into the color that we want. Once the extruder has finished purging the old color and transitioning into the new one, we should be able to see that our new color is the color that is being extruded. The printer will ask us if the color is correct. If it is, we can select yes. If not, we can scroll and say purge more, and it will push more color out. In general, the color switch is pretty thorough in that first time through, so we can select yes and then clear that old filament out. And then you'll scroll up and go to return. Before you prepare your print on the Prusa Slicer software, you'll want to take the flash drive from the printer with you. That way you can transfer your file to the printer. If your file is already on the flash drive, you can select print from the control panel and find your file. The latest save file will always be the top one listed. But in this case, we still need to prepare our print, so we're going to scroll to return, and we'll take the flash drive with us.
The slicing software we use is Prusa Slicer, which is designed specifically for Prusa printers and available to download for free at the Prusa website. This is where you'll upload 3D files that you find or create, adjust print settings if necessary, and slice into thin layers with a set of instructions the printer can follow to print out your model. The files you'll bring into the software will typically either be an STL, OBJ, or 3MF, and then the software will generate a G-code that you'll save on your USB flash drive and transfer to the printer. This is what the Prusa Slicer workspace looks like when you first open it. You have an image here of the build plate that reflects that real-world build volume, and this is where your models will appear when you load them in. The left-hand column are tools that will be available once we select the models that we load in, including Move, where we can change the location of our model on the build plate, scale, where we can resize our model and which will have an effect on the print time, and rotate, where we can reorient the angle of our model. We'll use the toolbar along the top for things like loading in and duplicating our model, and the panel on the right to adjust print settings, like layer height, infill, supports, and brim. And we'll also have access to some of those same functions as the toolbar on the left, like changing the placement of the model and resizing. Above that toolbar, we have different window tabs. You want to make sure that platter is selected when you first load your model in and when you're initially making any changes to print settings. Next to that are print settings, which you can go into if you want to make any more advanced or refined changes to the print settings. You can ignore filaments and printers since things should be set as they need to be, and Printables is Prusa's 3D model database where you can search for and download 3D models. You can also find that online at printables.org, along with a number of other sites where you can download models for free or at a cost. And in the lower left-hand corner, we have where we can switch between views of our workspace, the 3D editor view of our model where we can still make adjustments, or a preview of after it is sliced and ready to print. That will come into play once we press the slice button over here in the lower right. We'll be able to take a look at that later. Let's go ahead and find a model to load onto our build plate. From here, we could select the Printables tab and see the latest they have listed and featured. We could also do a search for something specific, something like this. If we find something we like, we could click on it to bring up the model page. Here, we might have some pictures of the model printed out, along with its 3D design view. If we scroll down, we can see some of the model details, including any recommended print settings. If we select the File tab to the right, we'll be able to download or retrieve the file we'd like to print. Some models have multiple versions to select from, or multiple files that may need to be fitted together. You can also access the Files tab by selecting Download at the top of the page. Next to Files down the line is Make and Comments, which might be worth checking out to see if anybody else has some recommendations for the print, or to see if there are any common issues with the print. People will also post pictures of their own prints, and might even just say how much they love it. If we wanted this particular model, we would first select Files. Here, we could select Download All Files, which would give us a zipped folder that we would need to extract, or we could download individual files, which we would open onto our build plate. So I'll select Download, and it'll save automatically in our Downloads folder, which is fairly easy to find. All files downloaded on our computers are wiped after they restart, so no need to delete it after you're finished, though you are free to do so. And that also means that if you want to hold on to that file, you'll need to email it to yourself or bring in your own flash drive to store it. But the quickest and easiest way to get our model on our slicer's build plate from here would simply be to select Slice next to the Prusa Slicer icon. As you see, it says Open in Prusa Slicer when you hover your cursor over it. So I left click to select, and we see how it loads onto our build plate. If I wanted to open that file I downloaded, we can select the cube icon with the plus sign here along the top toolbar. This will bring up that same dialog box where we can find it under Download and select and open it. To delete or remove a model from your build plate, you can select it and press backspace or delete, or even select this cube icon with the minus sign along the top toolbar. We can move the build plate around to get a better or different view of our model. Holding left click on the mouse will let us tilt the build plate, and holding right click will let us pan it around the screen. Using the mouse scroll wheel will let you zoom in and out. You can also do that by pinching and unpinching on a trackpad if you're using a laptop. One other thing to check before we begin is over in the right-hand panel that the printer selected is the original Prusa MK4S high flow 0.4mm nozzle. If you click on the drop-down arrow, that might be the only one we have installed currently. But if we add any more in the future, there might be more to select from. And you can double check down here on the lower right-hand corner of the build plate to see if it says MK4S. I'm going to go ahead and remove this model from our build plate by first making sure it's selected, then clicking on the cube icon with the minus sign on the top toolbar. Along the top toolbar here, we also have the option of undoing and redoing any actions. Now I'm going to show you another popular 3D database website where you can find a model to print called Thingiverse. That's where we'll get the file that we're going to print. I'll open up my web browser and in the URL bar type Thingiverse. There it is right there, so I'll just select it. Very similar layout to printables with a bunch of featured prints that you can scroll through. You can also search for a print specifically in the search bar here, and we're going to search for Kali. We have a number of options here, and we'll select this one. Again, similar to printables, we can select Download All Files to give us a zipped folder we could extract, or we can scroll down and see print details, read comments on the file, or find the file or files we want to print. If we hover over the arrow on the far right, we could download the file and then open it up in Prusa Slicer. We'll again find that later in our Downloads folder. Or we could open it directly in the slicer by selecting the 3-dot drop-down menu and Open in Prusa Slicer. We already have it downloaded, so we'll go back into Prusa Slicer and open it up. To do that, I'll select that cube plus icon, find my file, select it, and open up. Good dog. Now, we'll see about using some of these tools on the left-hand toolbar. First, we left-click on our model to select it. Now we have access to those tools. The first one is Move. We can move our model anywhere we want to on our build plate. We can move on specific axes by selecting that particular arrow, or if we click and hold anywhere on our model, we can move it freely on the build plate. If it's off the build plate, it'll shade out to blue, and we won't be able to slice or print it. I can drag it back onto the plate, or select the undo arrow on the top toolbar to return it to where it was. Over on the right-hand side in the Object Manipulation panel, I can also move it by changing the X, Y, and Z position values. Underneath the Move icon back in the left-hand toolbar is the Scale option. When I select that, my arrows change form and I have some cubes surrounding my model. I can click and drag those to resize on that particular axis, or if I select the peach-colored one, I can scale it uniformly. Scaling can have a major effect on your print time, so you may need to test out a few sizes to see what will fit in your allotted print time. You can also adjust the size of your model in the Object Manipulation panel by percentage of what it loaded in as, and actual real-world size. So, for example, if I slice my model at 100% of its size, that will take 19 minutes to print. If I double its size to 200% at these print settings, it will take 58 minutes. So double the size, but more than double the time. Everything will scale uniformly as long as this padlock is closed, and you can click on it to unlock uniform scaling. If you want to reset the model back to its original size, select the semicircular arrow on the right here. And with this box checked, it's currently set to inches. If you deselect it, it switches to metric. Feel free to use your preferred system. Below the scale icon on the left, we have Rotate. Models may come in rotated in their optimal way, but in case you needed or wanted to change its orientation, you can do that by clicking and dragging on one of the curved axis lines. You can also rotate it by a specific degree along a particular axis over here in the Object Manipulation panel. To reset it, select the arced arrow on the right. You can also change the orientation by mirroring a model on a given axis by selecting these little reticule icons next to the letters X, Y, and Z. Mirroring might be a matter of preference, or if you have multiple parts to a model and one side needs to be mirrored to print out its opposite pair. You may want to rotate a model to reduce the number of supports it might need or if it isn't laying flat, but typically the model should load in the way that prints best. And speaking of laying flat, you can place the model down on different sides or faces by selecting the icon underneath Rotate. Just click on any of the highlighted areas and that part will lie face down on the build plate as flat as it can. This doggo deserves a treat. Now we're going to move over to that right-hand panel where we can adjust print settings. The main settings that you might change, if any at all, are layer height, how high the print head goes up on each pass or layer, infill percentage, how dense the inside of the model is with filament, supports, toggle on and off depending on if there are overhangs, bridges, or more severe angles on your model, and brim, which helps your model adhere to the build plate. From the top, we have the Print Settings drop-down menu. It should be defaulted to Idea Studio recommended setting speed, and it should be good for most things. Those settings are layer height 0.2 millimeters, 10% infill percentage, supports on everywhere at 20 degrees, and no brim. You may need a brim on depending if your model has few or narrow contact points with the build plate, or if it's having trouble or looks like it might have trouble adhering to the build plate, or if you just want to be extra safe. To toggle it on and off, you can select and deselect the box next to it. These default settings should be good for most things where you can load your model or models in, adjust the size if need be, slice it, then save the G-code and take it to the printer. If you're doing something like an articulated model, one that prints in place and can bend, twist, and turn, you'll probably need to turn off supports. But if you would like to make any further or specific adjustments to print settings, this is how you would do that. If you select the Print Settings dropdown, you see that you have different layer height presets. The lower the layer height, starting at 0.1 millimeters, the more detailed the print. Lower layer heights will increase print time. For example, 0.1 millimeters will take twice as long as 0.2 millimeters since 0.1 needs 2 passes to cover the same distance as every single pass of 0.2. You may want a lower layer height if your model has a lot of curvature and angles, though something like 0.15 millimeters and 0.2 millimeters should be good for most things and give you a pretty detailed look anyway. If you were to change your print settings to any of these other profiles, like 0.15 millimeter speed or 0.25 millimeter structural, note that changes other presets like taking off supports and infill percentage. There's a couple other things that it changes in more advanced support settings like support angle and type that we'll touch on a little later. And the differences between speed and structural are how fast the print head moves during printing. Here we have recommended settings for both. Structural will take longer than speed, but sometimes speed can lead to weaker parts, so you can always select structural if you're trying to make something functional that might see a lot of wear. Trinkets and fidgets might work pretty well with speed though. If we wanted to change the layer height itself without changing any other print settings, we'd select Print Settings up here along this menu bar next to our platter view. We want to make sure we have layers and perimeters selected in the left-hand column, which it's the first one listed. Then, over in the center panel, we can change our layer height, including our first layer height, along with some other options that you're free to explore. One other thing while we're in here is that we are currently in beginner mode for our software, which gives us fewer and more basic options to choose from, which again should be good for most things. But if you wanted to see more advanced options and settings, you'd go up into the right-hand corner by the green hexagon where it says beginner mode, click the drop-down, and then change it to normal or advanced. As we change it to normal here, we can see it gives us more detailed options we can change. And if we go back to the Platter tab, we see we have more tools in a larger left-hand toolbar, and another section added to the right-hand panel with the file name. We'll change it back to beginner, but if you'd prefer to use more advanced options, that's how you'd do that. Under Print Settings, filament should be sent to PLA since that's the only one we carry, and you're going to want to make sure the printer is set to the MK4S high flow 0.4 millimeter nozzle. If you'd like to turn supports off, you'd click on the drop-down menu and select None. You can select support on build plate only if you want supports but don't want any starting on or building off your model. That's up to you. Supports are set to tree branch supports, or they're called organic in Prusa Slicer, and are needed if you have severe angles, overhangs, long bridges, or parts of your model that would start printing in midair. That way they have something that prints up and meets underneath them. Otherwise, you'll just have spaghetti start extruding with nothing to build on. Organic supports are easier to break off than snug or grid supports with smaller contact points on the model. If you change your print settings default, support preset changes to snug at a 40-degree threshold. To view and change that, you would go into your Print Settings tab, Support Material, and then actually change it to Normal View to see those more advanced settings. Here we see Overhang Threshold and Style. Again, we recommend a 20-degree threshold angle since this will decrease the number of supports you need and lead to a cleaner model when printed. For reference, 0 degrees is horizontal and would be something that extends out like a bridge, and 90 degrees is vertical or straight up and down like a pillar. Next, we have Infill. In order to save time on printing, the slicer will create a pattern to print out on the inside of the model. The higher the infill percentage, the denser the pattern and the more solid the model. Around 10% should be good for most things, but if you want a sturdier and maybe even more functional piece, you'll want something closer to 100%. The infill pattern is defaulted to grid, but you can change that in your settings tab. And then you can decide if you want to add a brim or not. Brims connect to the model, are about a layer high, and extend out a little ways. In our case, the collie is only connected to the build plate at its paws, so we'll add a brim. With all of our settings set, that's Idea Studio recommended setting speed, which is 0.2mm layer height, 10% infill, and organic supports everywhere at 20 degrees. Brim is usually off, but we turned ours on. With those as they are, and the model at 100% of its original size, we will select Slice Now in the lower right corner to generate our G-code. Once it's sliced, it will switch us over into preview mode. If we wanted to switch back to our model view where we could again move it around the build plate and use more of those left-hand toolbar tools and settings, we would switch it to 3D editor view by selecting the lower left-hand icon down here. But we'll go ahead and switch it back to preview mode. You'll have some info up here like how long it will take to print each particular part of the model, along with the total print time, which you can also find in the lower right-hand corner here above Export G-code. Normal mode is what you'll be using and referencing. We see here we have 19 minutes. This will let you know if you'll be able to get your print done in the allotted time you have booked. If you're planning ahead for a future print, be sure to give yourself time for setup and cleanup, including the time it takes the print head to heat and begin printing. On the model, we can see what our supports will look like, along with the brim build plate adhesion if we added those. We can use the slider on the right to view different layers and even what the inside of the model and infill look like, and the slider on the bottom to see the path the print head will take while printing. You don't really need to do anything with these sliders, but the layer height bar could come into play if you wanted to program in a layer height filament change for a different color. That's a little more advanced technique which we can go over if you're interested. In the lower right corner, the button that said Slice Now allows us to export and save our G-code to take to the printer. If we selected Export G-code, it would bring up our Save dialog box and we might have to find our USB drive folder. We can actually get to that directly by selecting the flash drive icon to the right here. Once that pops up, we can save our file onto our flash drive. We can save it with the name it already has, which includes the filament, printer, and print time, or we can give it whatever name we'd like. The file will be the first to pop up when plugged back into the printer, and also be the first one listed if you were to select Print from the control panel menu. If you have it in a submenu in your flash drive, you'll just have to navigate through folders on the printer's control panel until you reach it. I'm actually going to cancel this save here and make an adjustment to the model. So I'll go back into my 3D editor view, go over to the object manipulation panel, and change my model size to 125%. And we see with the padlock closed, it's scaled everything uniformly. And then reselect Slice Now. And I see here that my print time is now 27 minutes. Also note that anytime you make any adjustments to print settings, including size and position, you will have to reslice your model. Since these are the settings I want to print at, I'm going to select the flash drive icon to bring up the print dialog box, change the file name to Collie, hit Save, select this eject drive to safely remove my USB, and then take it over to the printer to start my print. Time to take this dog for a walk.
Now that we have our G-code saved to our flash drive, we can plug it back into the slot in the side of the control panel. When we plug our USB into the printer, it'll bring up the latest print that was saved. Since this is the file that we'd like to print, we are going to select Print. After you select Print, the printer will begin the process of printing your file. The first thing it does is the extruder comes to the front of the heat bed and does what it calls nozzle cleaning. After it finishes with nozzle cleaning, the extruder will move to the area where it's going to print at and do some probing to make sure that the bed is level. Once it completes that process, the extruder will return to the front of the heat bed where it'll heat up the hot end until it gets to printing temperature. Once the extruder reaches printing temperature, it will start with a test strip to make sure that the filament is flowing, and then it will begin your print. As the print runs, the display screen switches over to show you how much percentage of the print is complete. Over here, it'll also show you how much time has elapsed and how much time you have left. Along the bottom, it has the extruder temperature, the heat bed temperature, and the type of filament being used. And then we have some options we can select from right here. The first one is Tune. In that menu, if we wanted to, we could adjust the print speed. So we would scroll down to print speed, press the knob in, and now we can either speed the print up or slow it down. It'll go up to 999%, which if you have angles and curves on your print, it might make it look a little more rough. So generally about 100% should be fine, but if you need to speed it up a little bit, that's where you would do that. You also have the option where you can increase the nozzle temperature or heat bed temperature, but again that probably won't be necessary once you have your print going. If we select return, we'll go back to our menu, and from here, if we needed to, we could also pause our print or we could stop our print. So we might want to stop our print if something is going bad, like if it's prying up from the heat bed, or if spaghetti starts printing in midair if we forgot to add something like supports. So in that case, we would select stop, and it would ask us if we're sure we want to stop this print, and we would select yes. And then the extruder would raise and go back into its neutral starting position. When you stop the print, the extruder head may not have raised up high enough for you to clear removing the build plate. So in that case, we would press and hold the dial knob in, and it would give us the option to raise or lower the head. We'll turn it clockwise to raise it up high enough that we'll be able to clear the build plate without bumping into the extruder. You're going to want to remove the build plate to remove the printed object from it, whether it's a failed print or a successful one. So again, we can place our fingers under the corners of the build plate, lift up, and pull back away from the printer. From here, you can flex the build plate to see if the print will come loose. That doesn't look like it's happening here, so what you can do is place the plate down on a table and then use a tool to remove the print from the plate. To remove the print, you'll want to use a tool with rounded corners to prevent scratching the build plate. These are the only ones that we carry, and you can find them on the magnetic strips near the 3D printers. You'll also want to get a firm grip on it and choke up a little bit to make it easier to remove your print. And when removing the print, make sure to push the tool away from your fingers and not towards them to prevent any injury. We also have some protective gear available near the 3D printers, so if you would like to wear cut gloves, you can do that as well. So now we'll remove that print from our build plate by pushing away. And then we'll be sure to remove our print, including our test strips. But in this case, we have some scraps, so we could put this in our 3D filament bin, and we'll replace the build plate back onto the printer. To replace the build plate, we'll line up the notch on the back with the pins at the back of the heat bed. And then we can release. And if it's all lined up, we're going to go ahead and restart that print and let it run all the way to the end. Now with the print finished, it's time to remove the print from the build plate. The first thing you want to do is make sure the extruder is high enough where you can remove the build plate without running into the extruder. With the print head already high enough, we can remove the build plate like we did before, flex it to see if we can loosen the print, place it on a table and use a tool to help remove it if necessary. That pops it off. Be sure to get that test strip. Replace the build plate back on the printer and clean up your workspace. After your print is removed and you've cleaned up, you're all done. If you have any time left in your booking, you can set up another print. Otherwise, we ask that you return to the info screen for who's ever ready to use the printer next. You can also remove any files you wish removed from the USB drive. Now, it's time to set up your skills test.